Yo, what's up, guys? So today we'll continue doing our errors and checking among the prediction model. So we're given this data set that already have the prediction given to us, but still we will indeed continue, like, just try to predict it first. And alright, let's just get into the code. Nothing really to say. So first we'll just simply drop the this column, life expectancy, which is here. Oh, remember? So when you open the just like download the file, when the I will put it on my description section. And then for like any of these, the space is also an important part. So if I just put on predicted life expectancy, it will not work. You need to put down a space, predicted, and space life and space and expectancy. So, and definitely the best way is just to copy paste this, simply drop this. Oh, shoot. And then, excuse me. Access what you could do one, basically just dropping this column because this is our the answer that's already given to us. Not really the answer, but like the prediction that's already made. And then we'll just this time we'll use a linear regression model and x train, x test, y train, y test. You could train test split, which I explained in the last video. Test size, you could do I'll give this a 0.1, and x will just equal to data. So if you guys want to, I'll just give let me do this first. So the x will be all the attribute that will get fed, which is all these variables. So exclude this one, which is the answer, and this one, which is the prediction already made. And then x will equal to data dot drop. So it'll be life expectancy. Remember, there's a space there, and an axis will equal to 1. Y will just equal to data. So the y will always be like the answer or the target that our model want to predict, and then the x will be all the rest of the data that we want to give to the model so it can have the best prediction toward our target. And these are just simply that x train and y train is a subset, x test and y test is a subset. So the x train, it's the variables or the input in our training models, and then y train is a target or the answer of our training model, and then x test and y test, it's a new like data that the model have never seen, so we want to use it to like predict like this stuff. And x model that fit, which just make the model learn the x train and like and y train, which is a data set, print model that score x test and y test. So now we'll just let the model score itself to see if it's accurate or not. And pretty pretty sure there will be an error. Let's see. Why is it taking so long? Alright, just skip this part, I guess. Yeah. So it, like all the code is like correct. So why it's correct? And if the code is not correct, we need to think about is that what else we used. The library, but like the library is definitely correct. I believe so. And so if the code correct, then we can look at the data. Or you can look at this, but sometimes you might not be really able to like get a hang of it until you're like pretty, I guess, experienced and know what it means. So first of all, so there's two errors. One is the life expectancy. And then actually, it's still not finished. It says input X contains na, which means the our X contain this 9, which means like there's nothing there. So we go, so like our code is obviously correct. So we go back to our data, look at the X, and we look it. We see boom. There's nothing here. Wow. Nothing here. Nothing here. This whole column, there's nothing here. Nothing here. Nothing here. So this will be like a homework for you guys, which is just iterate through the whole all the x values, because the y is fine, and then if there's any error, delete the column. Like don't use any function. But for first of all, it's a homework obviously. Second of all, for the sake of time, I will just show you guys a simpler way, which is this function. We'll just drop every column, every row that have like nothing in one of its data set. And we can see 80% accuracy, which is very good. Like compared to the Avalon one we seen before. And one possibility might just simply be that there's more data. The more the data, like the higher the accuracy. Since there's like about 3,000 datas, and for the one before, like Avalon, I don't really know how much. Probably like 2,000, 1,000. And but like alright, so now what we will do is we'll continue to do some stuff about all the errors. So what we will do today is now we will look at our prediction and our life expectancy, and we will find the biggest error among the prediction and the actual correct answer, and what's the smallest, and then we will continue doing our mean square error upon it. So let's just get started. So we'll just use a very simple while loop because this video is pretty easy, I would say. I did too much C++. Alright, for I in range, length of data, life expectancy, okay, Control B, and then we'll do this min error, max error. So the min error will, like the max error will always start with like a 0, cause otherwise, if we make it like 1, what if the max error is like 0? There's all of the prediction is correct, then we will get 1, which is wrong. So max error will always be 0, and min error, like even if we give it a really big number, let's say a billion, but what if there's oh wait, but what if there's like a error, like the smallest error is greater than a billion? It's like a billion one. So we need to make it into this very interesting thing, like a quick fact called float inf. So this just makes the number infinity, which is pretty interesting. And so like there will be nothing like really bigger than that if we're like actually comparing answers. And then if so if data life oops life expectancy, the ABS of that, right, absolute value of data, and then is our predicted life expectancy, which is already given in the data set, minus this. However, you forget, because this one is just accessing the whole column. I will just access like each specific number inside. If the absolute value of this, if it's greater than let me think about it. If it's less the mean error, it will be equal to, like mean error will just equal to this very huge giant thing right here. I had no doubt. What's that? Go. Lose you. 我在录视频，你这个伟人。And then otherwise, I mean, yeah, we need to use else if, which is it just a leaf? Yeah. Because in C++ it's like else if. And I'm currently getting like very mixed up by these. And the max error will just, if it's like greater than the max error will just equal to this. And then we'll just print, we'll just see what is the main error and then the max error. So after we run the code, we see that, wait, what? Wait, date. Is it because when you use the .log I function? .ilog? Pretty sure. Because all of them are, let me see. Pretty sure. Now it should be correct. Line 19. What? Oh, in the knowledge form. I see. X into equal to that. Oh, I see, I see. Negative 4 point, oh shoot. Forgot about the ABS. Yeah. So this whole thing. What the frick? Alright, and then this. Alright, okay, so here. What? What the hell is that? So the main ABS. Okay, so it's like 0.1. So the smallest mistake is 0.1. And the biggest mistake is like 9. Interesting. Like, I mean, none of them actually got it correct. Which do make sense since the actual answer can be like decimal, and that would just make it like intensely harder because just a lot more numbers now. And then we'll do the mean square error. Print. If you guys do not understand what is mean square error, I will just quickly talk about it. Since so it's basically a function that used to call like look at what's the average possible what's like the average error for the whole like for 2 data set. And if you guys want to know like the math behind it, you can go to like my previous video. And yeah, okay. There's an error. What input include non? Oh, wait, what? There's a non in like the answer. That's wild. Okay, so I have an average incorrectness of 4.44. So like for every predicted value, which is this column, it have is off by 4.4 for the average. And basically that's it, the end of the video. Thanks for watching. Please subscribe and bye.